So I've got a tag team here. They're going to talk together about a project. Sam Lytle. After graduating from UNLV with a Bachelor of Science in Civil Engineering, he was hired at NDOT as an engineer. It was at NDOT that he fell in love with 3D visualization. And after 3 years there, he left to join Kinley Horn. And in 2014, Sam started a company called CivilFX, a visualization studio focusing on transportation and other infrastructure projects. Since starting CivilFX, he's been fortunate to build a team of talented artists and developers and be the visualization lead on projects such as Project Neon, Reno, Spaghetti Bowl, Boulder City Parkway, Complete Streets, and Centennial Bowl. And we have Nick Johnson, who's the chief of the Project Management Division of the Nevada DOT, where he oversees the state's major projects and alternative delivery program. Nick has been with the department 12 years in the transportation industry for 14. Nick's 8 years in the project management. He's managed more than $3 billion of major transportation projects throughout the state, including the alternative delivery projects such as design, build, and construction management. At-risk projects.
So honored to be here and excited to talk to you guys about visualization, the future of visualization, and kind of how we've worked with NDOT. As Kevin mentioned, I'm Sam Lytle with CivilFX, and I'll let Nick Johnson introduce himself and take it from here.
All right, good afternoon, everybody. Thanks for having us out here. We're going to walk through a number of things today. I think Sam's really going to get into the technical aspects of the models and things that he builds, and then I'm going to give a little bit different perspective as an owner and as a user, how we use it, how we benefit from it, and I'll give you a lot of examples and so on and so forth. So let me make sure. There we go, I got this figured out. And I apologize in advance if some of the text is off. When we uploaded it, it changed everything. So I had like 5 minutes. I tried to correct a lot of this stuff really quickly. But anyways, so as you can see, you have the AASHTO logo up there, the Innovation Initiative. So I think about 4 years ago, we started doing a lot of the VR 3D modeling for a specific project. And we had so much success with it, we submitted an application to the AII, some of the new innovative things that we're using on projects, and it was awarded. So, and really what that is, if you guys aren't familiar with it, is some sort of technology or innovation that the agency or DOT is doing out there that AASHTO helps support. We get out, we do a lot of outreach, we help other agencies or whomever in the industry, show them the successes we have, and then get folks, off the ground running with some of these things should they choose to use it. So really what we're looking at here today is some of this interactive visualization, the VR, the 3D models, so on and so forth. For us, we had, and I saw a bunch of presentations today. I mean, we had payment, I saw things on training and such, but our biggest thing that we've used it for is public outreach. And I know Cameron had talked a little bit earlier, and he actually had a really good slide at the beginning of his presentation to show this big room with all these boards around it with 2D maps and things like that. For us that are engineers, we could walk right up to it and figure out what's going on, and we could see it. But about 99% of the world, the people who show up to these meetings, the people who visit our website, the people who want to know how they're impacted or what's going on, they don't understand that very well. And it takes a lot of effort to sit down and go to each board and point it out. So we started thinking, how can we better educate the public? How can we better educate our stakeholders so they understand what we're doing? So one thought is, well, what's a better way than them being able to experience the project before it's even built, as an education tool, as an outreach tool. And so that's what we've done here, or I should say what Sam has helped or has built, and that we've been able to utilize to help educate folks on there. So really our goals and objectives, from the department standpoint, is just that. How do we get the word out on these projects? How do people how do we better communicate with them, help them understand it, and more importantly, educate them on that. From the AASHTO perspective, it's getting out and doing just this. Let everybody know what we're doing. If you are an agency or an owner, how can we help you utilize some of these same technologies for your purposes? And with that, I'm going to hand it over to Sam here for a little bit to talk about the technical piece, and I'll come back.
All right, thanks, Nick. So I want to give a little more detailed background, kind of where I came from and how Nick and I came to be on the same stage together. So I went to school at UNLV in Las Vegas, and during this time, I started messing around with some 3D modeling using tools like SketchUp or Revit, and I kind of fell in love with it, even though I was going to school in civil engineering. And I was fortunate, this was kind of the end of the recession in 2009, 2010. I was fortunate to get offered a position at NDOT as a rotating engineer. And so in early 2010, I started there as a rotating engineer. And for those not familiar with that program, they move you to different divisions, kind of in an effort to train you and prepare you hopefully for future management in the department. And so I was doing a rotation in roadway, and a project manager approached me and he said, hey, we have this project. It's kind of a system-to-system interchange. There's some conflicts with the bridge piers and this high-pressure gas line. And it's really hard for us to communicate what's going on. And we know you've done some 3D modeling. Is there any way you could generate something for us to take to this meeting and do this? So this is about 8 years ago. This is, I think, in 2011. And I said, sure, I'd love to. I love that stuff. And turns out that it was an effective thing. And turns out that that guy was Nick Johnson, back before, while he was just a lowly project management before he was running the place. And so another project manager, Adam Searcy, heard about that, and he said, hey, I have a diverging diamond, and those are really confusing and hard to explain. Can you develop an animation for that? And I said, sure, I'll try. And I had a free 30-day trial of this software that I was using, and so within that 30 days, I think I did 3 different quick models for these project managers, and they kept saying things like, wow, we used to spend all this money making these animations, and now you just did it really quick. And I was like, man, that's like as much as I make in a whole year. Maybe there's a business opportunity here. So I stuck in the career, I stuck at NDOT long enough that I wanted to get my engineering license. And as Kevin mentioned, I worked at Kimley Horn for a year, but in 2014, I did finally leave and start Civil FX, which would be a visualization firm focusing on civil visualization, a lot of transportation in that as well. And so one of the things while I was at NDOT that I envisioned, I was playing this game with my son. He was probably 2 or 3 at the time, and I was trying to get him out of my hair. And so I pulled up a game online that I found, and it was a Wreck-It Ralph racing game. And he's playing this game in a browser, and I started looking at it and thinking about it, and I was like, you know, there's not that much difference between these go-karts racing on this road as there is the roads that we're trying to communicate. Why can't we make this more interactive? Why can't we make this something as accessible as this game that I just pulled up for my son really quickly? And so the gears, not only of visualization, but of interactive visualization, were turning early on, about 7 or 8 years ago when I started at NDOT. So when I started Civil FX, things were slow for the first year or so, but we were able to be part of the design build team for Project Neon that was mentioned, which is the largest infrastructure project in Nevada's history. It's over $1 billion when they include right-of-way costs, and it's almost done now, but they rebuilt a lot of I-15 and some of the Spaghetti Bowl in the busiest stretch of highway in Nevada. Did I get that right? Nick's usually the one that's telling the details. So we get on with this design build team as the visualization lead, Civil FX, which I say we, it was basically me and a laptop, and then I had some contractors. And we had this budget that I felt big enough that I was like, maybe this is the project that we can do it interactively. And I have one of my brothers he's in the video game industry, and I felt like I had enough connections and people with talent that we could kind of turn Project Neon into a video game. And so that's kind of what we did. I presented it to them, and I think they were kind of like, who is this guy and what is he talking about? But they were just like, sure, why not? And we figured it out and we presented it. And fortunately, the department was able to give us a lot of freedom and leeway in that. And the result is kind of what we're sharing today, which is we've kind of reimagined what public outreach can be we've been able to, as Civil FX, we've been able to be a part of a lot of the amazing projects that NDOT has done, and a lot of those have involved this interactive visualization. So as I've focused my entire career on 3D visualization over nearly the past decade, I've thought a lot about where it is, where it has been, where it is now, and where it's going, and how we have been working as Civil FX and a lot specifically with NDOT on these projects to kind of push it forward into the future. And that's kind of the breakdown of how I'm going to talk through this. So the first topic is interactivity. So, you know, Nick mentioned how public meetings, especially in the past, you would go and there would be large roll plots on the walls, schematics, things that may be difficult to understand. The evolution of that was in the 80s, 90s, and even maybe 20 years ago, you'd see some simple wireframe 3D renderings right out of AutoCAD or out of MicroStation or Inroads. And then eventually they were a little bit more textured, but those early renders, even some of the renders today, they take a really long time to develop. If you're using something like 3ds Max or V-Ray, you can spend a whole week with a simple render farm to develop a good rendering. And so that's how it's been traditionally. Now you're able to use real-time interactive graphics using game engines. Cameron, I think you guys have used Unreal Engine. A lot of others have used things like Lumion. We've been using a lot of Unity 3D. And this allows you to view the project in real time and be able to move around without going through the process of doing those expensive and time-intensive renderings. And the graphic quality has continued to improve as the industry has improved as well. The future, I think, will look like multi-touch, real-time navigation, not just using PCs, but on any device. And so some of the demonstrations that I'll show you, you'll be able to do those not just using a graphics card like you have to use now, but hopefully on your mobile device, on your iPad, or whatever you have with you. Oh, wrong one. It's using laser pointer. Oh, how do I go back? Go back. What's that? Yep, there we go. I'll get it. There we go. All right, so this is our big TV. We actually have two of them now. It's developed a personality. We call it BK. It stands for Big Kiosk. And it's a 55-inch 4K touchscreen. You have to kind of special order these. The costs have gone down quite a bit. But we have this in conjunction with a gaming computer, and we take these to a lot of these public meetings that we do, not only for NDOT, but for other local public agencies. We develop this interactive 3D model, we take it there, and using the touchscreen, you're able to navigate it in real time. And it's been very effective in getting public feedback. We still have those roll plots on the walls, but we found if we have these big touchscreen TVs, they garner a lot of attention. There's big groups that they crowd around these big TVs. So this is the accessibility slide, and this is where I just showed that big kiosk, that big TV, and I've gotten in the habit of driving that around not only to public meetings, but also to conferences all over the Southwest over the past couple of years. And the first one that we have, it's 130 pounds almost, and the stand is it's quite a sturdy stand as well. And it's not easy to lug around. And so I'm hoping that the accessibility will continue to improve. A quick story on that. So in Las Vegas, if you've been there, it's pretty spread out. And the public meetings that we go to, no matter where the venue is, you can usually pull up my pickup in the parking lot, maybe to the handicap area, unload things. We have carts that we unload them on, push them into the thing, and we're good to go. So I had a request to go to downtown LA in April. So I went down there to give some presentations to some engineering firms. And when I was doing my planning for it, I kind of planned how I do for Las Vegas, where I was like, I looked in my GPS. It was like a 4.5 hour drive from where I live. And so I said, okay, I'll get there 15 minutes early. I'll back my truck up to the office. I'll unload it. I'll set it up and it'll be good to go. If any of you have been to downtown LA, you may know where this is going. So I get there, and I had also planned to bring some sandwiches this was like a lunch and learn venue. And so I get there about 15 minutes like my GPS said, and I went to pick up my sandwiches, and I realized that I had to go park down the block in a parking garage, go up to the top level because I didn't have a compact car that's park anywhere other than the top level, park in the parking garage, walk all the way down, get my sandwiches, go back to my pickup truck, go to a different parking garage, meet a friend that's there, get all my equipment, drive it up, or push it up a hill about a half mile to the venue. And long story short, we were about a half hour late and completely covered in sweat by the time we got there. And so a problem that I thought about a lot is we have this wonderful kiosk that when you're at a public meeting, there's no better way to see these 3D models that we make. But it's not a good long-term solution. It's not something that's accessible to everyone. So how do we get it into more hands? Cameron did a wonderful presentation about how they've kind of dealt with that same question. How can we make it so as many people as possible can not just see these things? We use YouTube, we use the news media when possible, we use social media, but to interact with these interactive applications that we're building. And so in the past, it was these image renders and video animations that I talked about. Right now, it's the PC applications and the kiosks. We've also done some virtual reality and driving simulators that have been very effective at getting public engagement. And we'll be at the open house later tonight where some of you guys can try some of the virtual reality and interactive applications that we built. And that's kind of where it is now. In the future, I think it's going to be more like what Cameron showed. It's going to be interactive on a web where you can go there and you can interact with the project directly. And we've done some testing with that as well, where you're able to render the 360 views and you're able to see a lot of the project. In the future, hopefully you'll be able to see the full project with the traffic moving, the trees moving, everything like you do in our PC builds. And the same with mobile. This is just a screen capture of kind of our own 360 viewer that we've been building in-house. We're able to look around, click on different things. You can switch between existing and proposed. You can also move around on the map as well. And so this is published. Once we have that 3D model in like I said, we use Unity most often, you're able to publish it out to something like this. All right, the next area where we're pushing into the future of 3D visualization is in quality. And this is something kind of like the rising tide raises all ships. You know, as we kind of dovetail on the video game industry and the visual effects industry, the technology and the talent and the hardware, they're all improving together, and we're able to take advantage of those improvements. In the past, there would be little to no context, maybe some basic texturing. I'm sure you guys have seen those renderings of 20 or 30 years ago, where we were just grateful to see something in 3D. We didn't care if there were buildings in there at all. Now the buildings, they're much more high quality. We're able to add things like trees with leaves blowing. Something that we add sometimes just for fun is AC fans spinning. So when you're driving over, it makes it a little bit more realistic. The terrain, the photogrammetry that they use is higher resolution. We like the 6-inch resolution aerials and DEMs. And then the texturing is even more high quality. And this is a little short video from Tropicana. This is an NDOT project. This one corner over here is the T-Mobile Arena where the Golden Knights play, and over in the other quadrant is where they're building the Raiders Stadium. And so this is an area of high public interest, not just for the public, but for the stakeholders and the business owners. And you think about it, if you're going to meet with stakeholders, either through a public hearing or a one-on-one meeting, if you go there, let's say that we're meeting either with Home 2 Suites down here on the left or In-N-Out Burger up there on the top left, if you go there and the building looks terrible, you know, that's the first impression that they're going to see, is that you don't even care about the building that they're being impacted. And so if you have a good representation of the building, you're already starting on the right foot. We found that in a lot of projects. And just because you can make buildings, I know, or just because you should, doesn't mean that you always can. And so there are budget restraints. And sometimes you have to pick and choose. Okay, we know that these are high interest areas that we want to use our budget on, and the buildings in the distance, they sometimes are just simple shapes. But because of the advances in software and hardware and talent, we are able to continue to move this until in the future, hopefully we'll have as high quality as we see in the AAA video game titles and the movies that we watch. Phasing. So I want to use this opportunity to talk a little bit about our workflow. So our goal most often is to build a realistic interactive 3D model of the project. The way we do that is the first step is we get the aerials and the terrain from the project if they've had it flown, because that's going to give us the highest resolution. That's kind of our base map. The problem with that is those aerials, they have the flat cars that you've seen. And so we actually have artists or interns, sometimes interns because it's kind of menial work, that they Photoshop and they clean it up and they make that our nice base map. And that's where everything starts. We then build most often an existing model. So even if the bridges are going to be removed, we still model them. If there's a section of roadway, we still model it. We want a good existing model. We start modeling the buildings, the trees. We have artists that focused almost exclusively on building this existing context so that we can make it as realistic as possible. The next thing is we start getting the CAD files from the designers. We're not designers ourselves, but we work closely with the CAD, either the microstation operator or the civil 3D operator, and we get those files. For those that are used to using those, the way that we like the format that we use most often is we like them to export it, the feature lines and triangles, and then when we model the surfaces using something called Rhino 3D, sometimes we use 3ds Max. And so we start building that proposed model, and then we bring it in, we chop up the existing model, and we have the proposed and existing model in the same space, in the same geolocation. And then we have a script where we can phase those, and you'll see that in just a second what that means. And so in the past, you were just focusing on getting just the proposed. You just want to show what your project was. Now we're able to do existing versus proposed. But in the future, I think we'll see more, not just existing versus proposed, but we'll see multiple phases. We did this on an NDOT project called Centennial Bowl, where there was 3 prominent phases, and we had them all modeled. And not only could you switch them interactively, and I'll have this at our open house tonight, but you could also use a shader so that it would highlight different phases and let you know which ones they were. One thing that I don't have on here, but I think will be crucial in the future as we continue to improve, is alternatives, showing various alternatives depending on what phase the visualization team gets involved in the project. And then also MOT, or maintenance of traffic. We've done some of that on Project Neon, where we're actually showing some closures. Once you have that investment of that 3D model, adding things like traffic closures and construction phasing is just a small percentage to the additional budget. This is a project on Las Vegas Boulevard. We actually developed this in pursuit of the project for a proposal, but we were showing how you can show a ton of different options really quickly, and this is rendered from an interactive model that we have built where you can just really quickly switch between all of those options. There was 9 different ones. So traffic, this is the area where I think is there's most potential and is most exciting, especially for us and our team. So in the past, if any of you have done this, maybe you just had cars there and you were taking a simple image render. If you were doing animation, it was probably keyframe animated. What that means is you were placing the car, moving 2 seconds and placing it again, and then you could keep doing that, which is a very tedious process. And the other issue is if you're doing an interactive presentation, let's say that you keyframe 2 minutes of animation. If you're doing an interactive presentation, the traffic's all going to reset every 2 minutes, which is very distracting. And so we needed a better system for interactive visualization. So our first step on Project Neon was we developed a system where it was basically just free-flowing traffic, just freeway projects, and so cars were just running all the time. When it was an intersection, we'd have to choose. Our car's going to be going this way or this way. If they weren't going, whichever way they weren't going, we would just have parked cars at the intersection. And those cars, if we had a 3-hour public meeting, they were waiting at that intersection for 3 hours. Eventually we made it where it was adjustable, where you can change how many cars there were, but they were still just free flowing. Well, now the future and what we're trying to push into is a smart traffic system and importing VISSIM, AIM-SUN, Synchro simulated traffic so that we can get the actual representation. And there are a couple different reasons why you would import VISSIM traffic. One of them, and we've used this on this Tropicana project that I was talking about, is that part of the project manager's job is to show why this project is being built. And if you can show in the 3D model, look, the traffic is really bad. In that project, we have existing no build, which is a 2040 VISSIM simulation. It says if the traffic is terrible, the queues are extended for a very long time, but then you switch to the proposed and the traffic's much more free flowing. And so not only are you using the 3D model for communication of the project and the design intent, but you're also using it to show why the project needs to be built in the first place and why the traffic congestion will be even worse. We've also had requests just to put VISSIM traffic simulation just so that the traffic looks natural. Now we've built our own we built our own smart traffic system. So over here on the left, we have VISSIM. We did this test. On the right, we have our own smart traffic system that we're developing in-house. And we were surprised to see how similar they looked aesthetically, especially from a distance like you look in these. Let me do that one more time if I can do it. Oh, that didn't work. There we go. So this is a diverging diamond project that we've been working on in Alaska, actually in Anchorage. And so this smart traffic system that we're developing is getting more and more sophisticated with every project that we work on. All right, so overall, I often think about the purpose of why we even do this. Why does a department invest money in doing visualization when in the past they may not have done? They built the project just fine without any visualization. We hear that from time to time, especially from the old timers. Why do we need this now? We've never used it before. In the past, the purpose was we just wanted basic design communication. We just wanted to get everyone on the same page. We just wanted to speak to those people that may not have the engineers' brain power to take that design and visualize it in 3D like a lot of engineers can do. Now we're able to do accurate design communication where we're actually using the CAD files and we're even doing some basic review and coordination. One thing that we've done a lot, especially the last year, is we've worked directly with landscape architects where they're constantly changing things and they'll just send those files to us. They'll send the texturing files, they'll send us their SketchUp files, we'll drop them in, they'll make renders, they'll make changes, and there's a lot of iteration. And I think as we move to the future, that's going to be an integral part of this whole process, is we make a good 3D model with all of this actual data, and we can work and we can use it as a design tool so that by the time the design is done, or by the time we're ready to start talking about it with the public, we've been using this 3D model already internally. And I think that's where the future of visualization is going to be, it's going to be things like constructability and design coordination and review. We use things like PDF and Bluebeam to review a lot, but in the future, maybe that review can all be done in a 3D model that everyone has access to. So with that, I'm going to turn the time back to Nick.
All right, well, I'm going to play a video for you guys. You guys have heard about this project that we did in Las Vegas, Project Neon, and we actually put this together as starting this AASHTO initiative here, but just kind of shows a public meeting with some of the folks who are there, the TV that Sam had set up with interactive driving simulators, how we've gone about educating folks and showing them. Is there volume on this? I don't know if they have it in the back there. She just left? I can come back at the end, that's fine. We can go back. We can we could skip ahead here, but I'll jump into why. So this was a graphic we put together, or that we found a few years ago, just on demographics, and this is just showing the workplace, and I think this extends far beyond the workplace. But if you see up there, millennials are getting larger and larger in the workplace. And what does that mean? Everything, communication is done right here. It's done right here. It's done on computers. It's done with technology. So I'm thinking here, how can I communicate with those folks in a way that they get it? And, you know, even with the millennials themselves, I think technology, you know, the way it's being used by other generations, I think everybody's using phones, smartphones, computers, and things like that. So again, how do we communicate to these folks? How do we make it so that they understand and become educated, you know, and use it, and really, how do you experience it? How do you pick up that phone, go to a website, pan around like Cameron showed, or pick up that phone, start clicking on future traffic, proposed conditions, existing conditions, and be able to go back and forth interactively, or even to some degree, we've posted the YouTube videos. If you have Oculus goggles, it's even better, but you can sit there and do, you know, virtual reality 3D, turn it up, turn around, pan, get whatever perspective you want. You know, what are the ways, how do we use that technology to communicate with these folks? So, I mean, really, you know, it's fast, it's mobile friendly, it's right there, you can experience it. And that's the point of it. So some of the benefits that I'll talk about. I'll give you a quick story. We were doing a EIS in Reno, and part of this project we're building adjacent to we call it the Reno Sparks Indian Colony, but basically a Native American community and environmental justice area. Early on in the project, I showed up to do a public presentation just for that community. And before I even walked in the door, that whole community was up in arms over this project. They were ready to take me out in the street and have their way with me. And it was like that the whole meeting. At the time, we didn't have enough developed yet, and we had Sam on board. We contracted with Sam to really, you know, go through and do some of the things that we're talking about. We went back 8-9 months later, same group of folks. This time, we had the big touchscreen TV, and we showed up there. And usually when we do our public meetings or hearings, we usually give it about an hour for people to go around, look at the boards, talk to the department staff, so on and so forth, and then give a formal presentation. Well, this touchscreen TV we had up there, same, you know, 40, 50 people gathered around this TV. As we panned around, we showed the locations, we could go to views from their backyard, you know, and show them. I even had a gentleman who was very concerned about, you know, part of their culture, praying in the morning when the sun comes up, with sound walls, you know, adjacent to the freeway. If that's gonna, you know, create a shadow over his, you know, back fence, and he'd have to do that later in the day, we just changed the time of day, and you can see where the shadows are. But point being is everybody crowded around this thing. We went through it. By the time I got to a presentation, probably 70% of those people left. They were okay with what we were doing. But it's all because they could, you know, rather than looking at a 2D map, they could come in now and actually we could give them an interactive experience. They could touch it, they could move it around, they could see it from their perspective of the world, and it helped them understand what we were doing. And it calmed that group down very, very quickly. You know, some other examples on that Project Neon, there was a McDonald's just off the freeway. And that property owner was very angry with us, thinking that nobody was going to be able to see the Golden Arches anymore when they drove down I-15, and they didn't know where to get off and how to get there. And we said, come down to our project office. In the project office, we had a touchscreen TV set up. He came down, we sat down, we could put him in a car's perspective. At any point along the interstate there, panning over to see that you could see those Golden Arches from a mile away. And he knew exactly where to go. And instantaneously, that calmed him down. He was good, never heard from him again. So this type of technology has allowed us to really mitigate our risk, especially from a public perception standpoint. Sam showed the phasing option. When you talk about decision making, being able to show up, and I can just open my laptop and just boom, 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 boom. Here's a whole bunch of different options. You know, when you're in the NEPA process, going through that. I mean, it gives you a lot of flexibility to demonstrate the different options and come to decisions very, very quickly. So there is a number of benefits, and I think just in general, it's getting with the times. I mean, we're probably still behind the times in terms of technology, but it's just a step forward in having us, keep up with the rest of the world and what's going on. All right, so this is, part of this, we also try to give some of the owners or agencies a sense of what type of investment is this for a project. Now, I'll use, again, back to that project Neon, we spent close to $1 billion on that project. And I think in this case, for all the modeling, and the modeling went, just beyond doing a 3D model, I think we spent about $250,000. That $250,000 we spent on this, we got back tenfold. I mean, it was a tremendous success, and that covered the, virtual reality, doing, virtual helicopter rides. You can pan around the whole thing. Driving simulators, like Sam said, he basically set it up like a video game. You can come in, we had a driving simulator. People could drive the project. So if they couldn't figure it out from a 3D model, now here you go, drive it. It's not even built yet, but now you can figure out your way to work or whatever, and you can drive it before it's even in place. The interactive touchscreen TVs. We even did traffic control. So our design build contractor, when that got laid out, Sam dropped it in the model. We were creating videos. We were putting those out on the website. They were being posted on our web app. Even the media down there on the TV stations were using these things to show people how to get around during construction. So there was a lot of uses that we got out of that money. Now, it is scalable, so it all depends on how elaborate you want to get into these models and how much detail you want to put in. If you just want some block buildings and a roadway, you could probably do it really cheap, especially if you're in a concept level and you just want to show things. But if you want to detail out every little thing, it's going to cost you some more money. I think even in Reno, we had a casino right next to the freeway there that had this big electronic billboard sign. And even in the model, it was changing advertisements and things like that. So that's the type of detail you can get to if you really, really want to do it. And I think, kind of to wrap this up, and we'll open it up, I know one of the things that we've done as part of the ASHO initiative is also develop a scope of services, for owners and agencies. So if they want to get into this type of thing, we develop it, we post it on the website, so they can go through a procurement to get folks, to get different companies on to do this type of work, and then just continue this outreach to the industry and some of the benefits we've had, and if we have any new advancements of that, just continue to communicate that to everybody. And I think Sam is working on some other things as well.
Yeah, I just appreciate Nick and his politically correct explanation of the outreach on Project Neon, and using the example of McDonald's. The most common example was the mini strip clubs that are right across there that were thinking that we were going to block the view of their billboards and their signage, and so effective for a lot of uses. So yeah, I mean, we're going to continue to push the technology with each new project that we get. A lot of them, which I'm sure will be with Nevada Department of Transportation, with other agencies. One thing that we've started looking more into, when I worked at NDOT, I was trying to do visualization myself, and there are not a lot of good visualization tools for civil engineers. There are some, but there are different issues with each of them. And so we've started talking internally about building better visualization tools. And so over the next couple of years, we're going to start developing our own tools where we integrate some of the smart traffic, the graphics, the phasing, the things that we've developed internally, and making those available to others, so that hopefully we can, as an industry, come together and improve the visualization as a whole. For a variety of reasons, visualization in infrastructure is quite a bit behind visualization in architecture. I mean, I think one of the biggest reasons is because architecture is a simple visualization problem to solve. They don't have to mess with things like terrain models or 7-mile-long corridors. Traffic, yes, but we can bridge that gap. If we're 20 years behind, maybe we can work together and maybe only be 5 or 10 years behind. If we just, I think part of it too is what's acceptable in the industry. If we just keep pushing the boundaries and the quality with each new visualization that we do, we're going to work together. And like I mentioned before, the rising tide raises all boats. I think we can work together to do that. And so that's all I have. Thank you.